Hello everyone, I am Amit Kumar from IT department, assistant professor. The topic is CPU scheduling, which comes under the operating system. So what is CPU scheduling? CPU scheduling is a process that allows one process to use the CPU while another process is delaying in standby due to unavailability of any resources such as input or output. Actually, in today's we are working as in multiprocessor systems. So the multiprocessors works as a most of the processors are concurrently working. So the CPU scheduling works as that the process that allows one process to use the CPU. Actually, what happened, there is a CPU time, so the CPU has to use it. So any one process can use a CPU in while one time. The other processes standby because another process has to wait. So for that we are making full use of CPU. So we are using the CPU scheduling algorithms. So what is the purpose of CPU scheduling algorithms? To maximize the CPU utilization, means the maximize the CPU time utilization, or means the CPU can't be idle. So for that the CPU can use multiple process at a times, and they can use the maximum utilization of CPU. Fair allocation of CPU means we have to allocate the CPU time fairly. That means you at a one time one process can use the CPU, and another time the one process can use the another process can use the CPU time. Maximum throughput, the output would be max. Minimum turnaround time, minimum waiting time, and minimum response time. Because these three are the main for purpose for the CPU scheduling algorithm to use, because there is a minimum. For that we have to minimize the turnaround time, waiting time, and the response time. Because for that the when the process is coming to our CPU, it works very fast. So for the maximum utilization of CPU, we have to minimize these three: minimum turnaround time, waiting time, and the response time. So the terminologies which we are going to use to solve the CPU scheduling algorithms are: first is arrival time. It means the time at which the process arrives in a ready queue. Means it at what time the process is coming at the CPU. So that is known as the arrival time. Second one is completion time. Time at which the process completes its execution. It means the time at what time the process is having the executions fully in from the CPU. That is known as the completion time. Third one is burst time. Time required by the process for CPU execution. It means the how much time CPU is going to be take for the execution of that time. It is known as the burst time. Next is turnaround time. Time difference between the completion time and the arrival time. It means how much time it's get to be executed. Means when the process has arrived and when the process has been completed. The difference between those two times are known as the turnaround time. Waiting time means the difference between the turnaround time and the burst time. Means how much time the CPU has took the execution, and the time difference between the arrival time and the completion time. That is known as the waiting time. These terminologies which we are using to solve the problems for the CPU scheduling algorithms. Next, there are two types of scheduling methods: primitive and non-primitive. Primitive means the primitive scheduling is used when a process switches from running state to running state, or from the waiting state to running state. It means primitive means we have to give the priority that the process has switches from running state to ready state. Means it is it means it is in the running state, and they are coming into the ready state for the process, and we have to execute it. Non-primitive scheduling is used when a process terminates, or when a process switches from running state to the waiting state. It means the process has to complete its running time, and it has to be wait. That is known as the non-primitive scheduling. Now the first scheduling algorithm is first come first serve. It means first come first serve scheduling algorithm states that the process that requests the CPU first is allocated the CPU first, and it is implemented using first in first out queue method. It means the we can say that first come first serve means if you have if you want the CPU time first, then it give you the first. It means the first come first serve means first in first out. Okay, the characteristics of the FCFS are: FCFS supports non-primitive and primitive CPU scheduling algorithms. FCFS support both the types of the CPU scheduling algorithms. Tasks are always executed on the first come first serve concept, means if the process has come the first, then it would be executed for the first time and then further on. FCFS is easy to implement and use. Obviously it is easy, and because when the process is coming for the first time, first use, first come first serve. This algorithm is not much efficient for the performance because the waiting time is quite high, because if the process has the low burst time, so we have to execute that one, because it will be executed and the CPU will not be idle. But for this FCFS, CPU should be idle for that time, or the process has to wait maximum time. So that's why this algorithm is not efficient. Now the advantages of FCFS: it is easy to implement because it is first come first serve method, and these two are the advantages. And disadvantage: it is suffering from the convey effect, and this algorithm is waiting time is much higher than the others algorithm, and it is very simple and easy to implement, and hence not much efficient for the CPU. Now as I have took an example for the solving for the first come first serve, there are 5 processes whose arrival time and burst times are given below. So we have to find the completion time, turnaround time, waiting time. Okay, so for the finding for this one, we have to take the chart. That chart is known as the Gantt chart. Okay, Gantt chart. So for Gantt chart, we are taking, for that we are making a chart for solving the problem. So P1 has the arrival time of 3, P2 5, P3 0, P4 5, P5 4. These are the arrival times of the processes. So for the first come first serve, we are taking that the arrival time is 0, because when this is the CPU time, we can say that this Gantt chart is taking the CPU time. So it is starting from the 0. For this 0 time, P3 has arrived. So P3 has arrived, and how much time it has been run? 2 times, means we have to add here. Okay, 0 plus 2, then it is 2. Okay, for 2 times, for these 2 times, anyone has came for 2? No, there is no anyone has come around the 2. So CPU is idle for the 0 to 2 to 3, because is that time it is CPU would be idle, because CPU idle because the next arrival time is 3. The next arrival time is 3. So for 2 to 3, the CPU should be the idle, and for 3, P1 has been arrived. P1 has been arrived, because first come first serve, P1 has been arrived, and it is has 4 time. 3 plus 4, 7. Okay, then that 7 has arrived at the all this one. So all the process has arrived for that one, 7. So we are taking the next one. So P5. Now P5 has the arrival time 4. So 3, 10. Now next, there are 3 processes has been processed in the CPU, P1, P3, P1, P5. Now P2 and P4 has been left over. So for checking for this, the arrival time for the P2 and P4 are the same, but we are if the arrival time are the same, we are taking the lowest burst time. We are calculating for the first come first serve, so we are taking the lowest burst time. So for that, P4 is the first one, so P4 will run and 1 time, 11, and last P2, so it has been 3, means 14. So this is the Gantt chart, and this is the total completion time of the process. So we are taking P1 has completed the 7, completion time 7, P2 14, P3 2, P4 11, and P5 7. This is the completion time of processes for this P1, P2, P3, P4, 5, P7 from the Gantt chart. Now the the turnaround time. Turnaround time formula is that we have to minus from completion time to the arrival time. 7 minus 3, 4, 14 minus 5, 9, 2 minus 0, 2, 11 minus 5, 6, 7 minus 4, 3. This is the turnaround time. As you are seeing this formula from this one, completion time minus arrival time. This is the formula for the turnaround time. Completion time minus arrival time, and the waiting time is turnaround time minus burst time. So from this formula, I have calculated this one, turnaround time. Now waiting time, turnaround time minus burst time. 4 minus 4, 0, 9 minus 3, 6, 2 minus 2, 0, 6 minus 1, 5, and 3 minus 3, 0. This is the waiting time. So for this, the waiting times are for the processes 0, 6, 0, 5, 0. So we have to calculate it, average of TAT and average of waiting time. How much average is there? So for that, we have to calculate this one. 6 plus 5, 11. So 11 upon 5. And for this, 24 upon 5. So this is the average TAT and this is the average waiting, as I have calculated from the mouth, but it can be correct or not. Okay, it is calculated. So from this we are calculating the first come first serve. So we are calculating completion time, TAT and waiting time. Another one column is here, response time. For that response time, you have to check from the formula that when the process has been come through the arrival time, means for the first time it came. So it is not compulsory to calculate the response time, but it is important for that one. This is the by this way we are calculating the first come first serve formula for the for CPU scheduling, and you can say you can check that formula from that. These are the maximum values and average waiting time is the more. So we have to reduce for that one, but for this FCFS will give more waiting time for the process. The next is shortest job first. Shortest job first is a scheduling process that selects the waiting process with the smallest execution time to execute next. This scheduling method may or may not be primitive, significantly reduces the average waiting time and the other process waiting to be executed. The full form of SJF is shortest job first. It means the job which is the shortest, they have to run the first, and after that we are checking by solving of numerical, we are checking the shortest job first. The advantage of shortest job first is to reduce the average waiting time because it is the better than the first come first serve scheduling algorithm, and SJF is generally used for long term scheduling. Disadvantage is it has been the starvation. One of the demerit is starvation, and it is complicated to predict the length of the upcoming CPU request. Okay. For this we are taking that problem, process ID, arrival time, burst time, we are checking for the shortest job first. For this I am taking for non-primitive. Okay, shortest job first are two types: primitive, non-primitive. Non-primitive is saying as a shortest job first. Primitive is called as the SRTF, shortest remaining time first. Okay. So for that we are calculating again completion time, turnaround time and waiting time. Again we have to make a Gantt chart. Okay. So for Gantt chart we are taking 0 because the CPU will start from the 0. So for that one we are taking the arrival first. For the first time we are taking the arrival. Again we are checking on the burst time only, how much remaining of for that one, but the process has to arrive in the CPU, then we can take the burst time. Okay. For 0, P3 is coming. Okay, P3 is coming and P3 has run for the 2 times 2, but for that CPU is idle for 3. Okay. So for 0 to 3, 0 has been run and 3 has been came. For that P1 will run again P1 and add 7, 4, then it will be 7, but these 3 has been come in the CPU, but we will check which process has the minimum burst time. So this has been the minimum burst time, okay, P4, but these two are the same, but this is the minimum. So P4 will run, P4 again 8, P4 has been executed. Okay, now we will check P5, P2 and P5, but these burst times are equal. So we will check the arrival time which has been came. So P5 has been came first. So P5 3, again 3, 14, P2 14. Okay, so this is the full completion time for that one, means for the shortest job first for non-primitive. So we are completing for P1 7, for P2 14, P3 2, P4 8, P5 11. Okay, now TAT CT minus AT. Okay, 7 minus 3 4, 14 minus 5 9, 2 minus 0 2, 8 minus 5 3, 11 minus 4 7. Okay, waiting time TAT minus burst time. Okay, 4 minus 4 0, 9 minus 3 6, 2 minus 2 0, 3 minus 1 2, 7 minus 3 4. Okay, the average calculate 6 plus 2 8, 8 plus 4 12, 12 divided by 5. Okay, average waiting time and average that would be okay, this would be the average TAT and average waiting time for the shortest job first. This is for the non-primitive. And how we have calculated means this is the CPU idle. Okay, the CPU should be the idle, and we are calculating the lowest burst time. The program has been executed for the CPU, so we have took the burst time priority based. When the process has been arrived, then we are taking the burst time. Next, shortest remaining time first. As I have told you, this is the primitive type. Okay, the primitive versions of the shortest remaining job SJF. Okay, algorithm, and it is all allocated for the job closest to the completion. This algorithm required advanced concept and knowledge of CPU time required to process the job in an interactive system, and hence can't be implemented there. But in a batch system, there is desirable to give preference to short job, as RT algorithm is using. For the preference of the desirable for the batch system, we are using the shortest remaining time first. This is the primitive type of SJF. Okay, what is the advantage? SRTF algorithm makes the processing of the job faster, and SJF algorithm, given its overloaded charges, is not counted. Allows for easier management of library updates or replacement without recompiling the programs. Disadvantage for this, the context switches is done a lot more times in SRTF than the SJN, and consumes CPU's CPU valuable time for the processing. This adds up its processing time, and it diminished its advantages or fast processing. It means the context switching is more and more in SRTF. So for that one, it consumes the CPU's valuable time more. That is the disadvantage. For that, we have taken that numerical for SRTF, but how we are checking, we are taking in the primitive. So for that, completion time, turnaround time, and waiting time. Okay, now Gantt chart. Okay, 0. For 0, we are taking 1 units, because for that it is easy to calculate which process has been came for the CPU for that one. So we are taking the 1 units difference for that one. 0, P3 has been came, P3. Okay, and this would be the 1. So for 1 times anyone has been came? No. So for that, P3 will be run again, because P3 would 2 to 1. Okay, again P3 2, then it should be the 0. Okay, P3 has been run, or we have checked. But for 2 times, any has been arrived, any process has been arrived? No. So for process has been arrived for 3, so this would be the CPU would be the idle. CPU would be the idle. For 3 times, P1 has been arrived. So P1 has been arrived, P1 has been 4, and this would be the 3. For 4, any process has been arrived? Okay, yeah, process has been arrived, P5. But we are checking that, these 3 and these 3 is equal. So for that one, we can take P5 also and P3 also, but for that we are taking the least arrival time. So we are taking P1 again for 5, and P1 would be the 3 to 2. Okay, now 5, all process has been arrived, but for that, who is the minimum? 2, 3, 1, 3, this P4. So P4 will be come in the CPU, and it will be 6. Okay, again we are taking the long we have to take. Now we are checking this one. So again P1 will be run because P1 is lowest 7, P1 would be the 1. फिर again we will check 3 1 3 3, then P1 would be run 8. Okay, this would be the 0. Now we will check this 2, who is the lowest, then P5 will run. So P5 will be done for the 3 times 0, and then again P2 will be run for the again 3 times 40. So this is the SRTF Gantt chart. We are taking 1 units. I have took 3 because here the 3 difference, because if you will run, then it would be the 3 2 1 1 1. So I have took the, so the completion time of P1 would be 8, P2 14, P3 2, P4 6, and P5 11. This is the completion time of the all the process. So TAT CT minus AT, 8 minus 3 5, 14 minus 5 9, 2 minus 0 2, 6 minus 5 1, 11 minus 4 7. This is the TAT, and waiting time TAT minus burst time, 5 minus 4 1, 9 minus 3 6, 2 minus 2 0, 1 minus 1 0, 7 minus 3 4. This is the waiting time. So this is total 11. So this is the total. So average of TAT would be 24 upon 5, and average of waiting time would be 11 upon 5. So you can check 5. So you can check whether this is the this reduces the waiting time. Okay, so we have to take that one. We have the least waiting time, because for that we have to for that we are calculating these CPU scheduling algorithms. Now another one is priority scheduling. It means priority scheduling is primitive priority scheduling algorithm is a primitive method of CPU scheduling algorithm that work based on the priority of the process. In this algorithm, the editor sets the functions to be the important, meaning that the most important process must be done first. Means the highest priority would be the given, that would be the performed to be the first. Okay, and the lowest priority would be the last. In this case, any conflict there is when there is more than one process is equal value, then the most important CPU scheduling is based on the FCFS. If there is any issue, then we use the FCFS algorithm for that one. Okay. Now the advantages of priority scheduling: the average waiting time is less than FCFS, okay, and it is less complex. A disadvantage is that one of the most common demerit of the primitive priority scheduling is the starvation problem, because it is have to starve means the process has to wait for the longer amount of time for the CPU, and it is known as the starvation problem. Now again we have given this problem, process ID, arrival time, burst time, but with this we have given the priority. This is the highest priority and this is the lowest priority. Okay, we have checked with this one, and you have to solve this problem. So for that you have to check the completion time, turnaround time, and the waiting time. For this, for that formula, as I have formulated you how to calculate it, but for this how you have checked for that one? For the Gantt chart, we will start from 0 because CPU time is having the 0. So we will check for that one. So P3 will start. P3 will start for this one. Hana, P3 will start and it will run for the 2 times. For 2 because and this is the highest priority. Now for 2 to 3 CPU would be the idle because 3 has to be started. Okay. So CPU would be the idle. Again we will check which have the priority. 3 has been arrived and which has the priority. So this is the priority. So burst time is the 4. So P1 sorry, P1 has been run for the 4. 7. Again we will check whose priority is for that one, 2 to 3. Then this one P4 will be run. 7 P4, all the process has been arrived. Then P4 one time 8. Then P2 3 times. Then P5. This is the Gantt chart for the priority base. For we are checking the priority. So the completion time for P1 7, P2 11, P3 2, P4 8 and P5 14. TAT CT minus 80. So 7 minus 3 4, 11 minus 5 6, 2 minus 0 2, 8 minus 5 3, 14 minus 4 10. This is the TAT. Waiting time TAT minus burst time. 4 minus 4 0, 6 minus 3 3, 2 minus 2 0, 3 minus 1 2, 10 minus 3 7. So this is the TAT and wait time. So the average of TAT would be 25 upon 5 means 5 units, and average of waiting time would be 12 upon 5 means 2.5 2.4 sorry 2.4 units. Okay, for that we are calculating like this. We are calculating this type of CPU scheduling algorithms for this one. As we have read FCFS, SJF, SRTF and priority scheduling for the CPU scheduling algorithm.